Welcome to the Carasoft Data Center Innovation Series, where we dive into the trends and issues shaping the future of data centers in the public sector. I'm your host, Carasoft Consulting CTO Scott Robon. Today, we're going to focus on networking in the next gen data center, and we're thrilled to have Greg Bensimon, a data center sales specialist from Juniper Networks, joining us to talk about what he's seeing across his engagements in the public sector and US federal data centers. As we see the continued explosive growth of the data center industry across all sectors, we know that networking plays a key role in making data centers function. Well, Greg and I know this. Not everybody has the same appreciation that Greg and I do. Um, Compute has to connect to storage. Application components need to communicate across physical and virtual machines. And application architectures often span across wide area networks into multiple clouds and multiple data centers. Greg is going to help demystify some of this for us today. Greg, welcome. It's great to have you here. Can you give listeners a brief intro on how you got into the data center networking space?
Sure, Scott. Thank you. It's good to see you again too.
Same.
That's been part of my natural evolution here at Juniper. I've been, I've done IT my entire career back from the days where we called it data communications. Um, Most of that has been WAN, but over the course of the last 10, 15 years or so, particularly as the technologies we're using in the WAN started to make their way into the data center, it became sort of a natural evolution. So I've been supporting data center across federal, commercial enterprise, and even SP now for about 15 years.
I know you have lots to observe from this. Let's ease into it slowly, and we'll start out with some general trends.
Okay.
So from what you're seeing, what's happening from the evolution of speeds, feeds, and architectures. What are you seeing there?
Yeah. Well, things are always getting bigger and faster. And I think the data center environment tracks more closely against Moore's law than any other aspect of IT. The modern data centers is, in a lot of ways, a very large distributed computer. It's a design
Right.
that allows us to place and scale compute and storage both quickly and flexibly, and to do so using relatively simple components.
Well, Jensen Huang has been out there saying, the data center is the new unit of compute, right?
Mhm.
So it's the new mainframe. Sorry, I don't want to
Yeah.
disrupt you.
No,
Yeah,
no, no.
yeah.
So
But yeah,
go ahead. I'm
go on.
sorry.
Well, from an architecture perspective,
Mhm.
would you say things are getting simpler or more complex? What's that interplay between simplicity and architecture and scalability?
Mhm. Well, I think the reality has been that the networking has always been complex. It's just been a matter of what we've become accustomed to over time. So I don't know that now is particularly simpler or more complex than yesterday, but it is certainly complex in different ways. The good news, I think, is that the modern data center is more scalable and resilient than at any other time in our history. So, whatever we think about the complexity, I think we have the opportunity to build something more robust than we ever could before.
Do you see real lessons learned from what the hyperscalers have done to drive scalability and resilience?
I do, absolutely. The most important thing that we can learn from the hyperscalers is that we want to build things out in a very repeatable way. We don't
Right.
want one-offs. We
Yeah.
start from a set of very well-defined components, things that we can understand really well, both fundamentally and from a testing perspective. And then we reuse those things over and over and over again. I've had lots of folks tell me over the years how much they want to be like Google or they want to be like Amazon. A lot of folks tell me that from the standpoint of building their own automation. Uh, you probably don't have the software engineers that a Google or an Amazon has, so I'm not
Right.
sure how practical that is. But if you really want to follow that model, then think about how you can build in a way that is standardized and repeatable and testable. That's the lesson to take, I think.
For sure. What lessons learned come out to you, from the old way of data center build out to how things have to be done today and where you see things going?
Right. Let's actually take that a particular direction. I spent a lot of the last couple of years talking to folks about how they're going to bring AI into their environment, their enterprise,
Sure.
not just from operations, but also from actually we want to run AI in our space, and that's
Right.
been really interesting. And I think it's done more to change the way we do, obviously, the way we think about offering services and compute, but also just the way we build data centers. It's made a significant change. If you think about the old days, an entire rack might be 10 to 15 kilowatts of power. And now we've got single servers consuming that much power.
Yeah.
Um, and that leads to lots of changes in terms of how we place resources in the data center. And I have seen projects come to a complete stop because the folks who were developing that project never even realized what that was going to mean.
Right.
Um, the power is very hard, but that I think is the more achievable aspect to take on. The cooling becomes a real challenge. Um, so I've seen things sort of evolve from, well, we're going to space out our racks now because they can't be side by side anymore. We started seeing this idea of chilled door racks. So the
Hmm.
idea here is that we could take the chilled water and put it through the back of the rack. And the reason for doing that now is that as we blow that hot air out of the equipment, it hits that chilled door. And what comes out beyond that then is sort of ambient like temperature.
Sure.
And we're getting to the point now where we're really starting to see what they call like cold plate technology. So let's take
Hmm.
that chilled liquid directly into the components themselves and chill the CPUs and the GPUs and the ASICs directly with that. Um, so obviously that's been a big change. Um, that's that's a local problem or a data center specific problem, but it's also a global problem. We're actually seeing a resurrection of the nuclear industry in the US right now
Sure.
to satisfy the needs of Google and Amazon and the other big providers in that space. Um, and then from just the pure networking standpoint, we're seeing a lot of changes in the way traffic behaves inside of a data center, especially on the training side of AI. Traditional enterprise data center, I like to think of as sort of the quantum foam. It's a lot of little flows popping in and out of
Right.
existence all the time. That's not the case in a training environment. We have many fewer flows, and those flows are humongous compared to pulling down an image off of a web page, for example. And that's led to a real breakdown in the idea that we can just throw more bandwidth at the problem inside the data center and scale that way. We're at a point now where we really do need new tools to enable the ability to share that bandwidth more effectively.
Well, to oversimplify it, there is the air traffic control model, right? Where I don't let a plane take off unless I know it has a place to land, right?
Right, right.
Certainly things can happen in flight, but
Hmm.
same with packets for AI processing. We don't let them take off unless we know there's a place to land. And
We
that
certainly
stocha
try.
sure,
Yeah.
sure, sure.
Yep.
That stochastic variability that you have in the traditional, enterprise data center,
Hmm.
with lots of flows, ephemeral, coming up, going away, some larger flows and really big flows here and there, but in no way, mimic, what's happening for, AI model training. Yeah.
Sure. Absolutely. I mean, it used to be, in an enterprise data center, traditionally, if you get a big flow like that, well, you just wait a couple of clock ticks, right? And
Right.
that flow's done and we can recover. That's not the case here. If we have some sort of a congestion anomaly or congestion phenomenon happen inside the network, it's not just waiting a couple of clock ticks. We've actually killed an entire process that needs to be checkpointed and restarted. So,
Yeah.
so the stakes are much higher.
And the dependence of like snapshotting the training model at a certain point in time and having network connectivity to make sure I actually save that snapshot again puts real importance on this is the role that the network plays as that circulatory system.
It
I don't know
does.
if I want to whether it's the network or whether it's the cooling system. I guess we got two kinds of circulatory systems here, but
It's the bus. It's a big computer, and this is the
that's right.
bus. Yep.
Yep, yep. Cool. Well, so, from a new construction versus upgrading brownfield, how would
Mhm.
you compare and contrast what you're seeing on that front?
Yeah. Well, again, we've just talked about how AI workloads are impacting the physical state of the data center. Um, I really think it's more likely that we're going to need to think about how we place workloads and expanding them into public clouds and colos. I think it's less about traditional brownfield versus greenfield. I think it's a lot more about where we're actually going to plant those fields in the first place. And there's a real decision point that has to be made about, do I put this in public cloud? Do I
Mhm.
contract someone to do this work for me or take it on internally? And if I do take it on internally, it probably doesn't go into one of my existing data centers. I'm probably going to have to find some space somewhere else.
Yeah, there is a cloud analogy here, I think, where
Mhm.
there was initially that real hesitation to, you know, are you kidding me? Put my very sensitive data. into somebody else's, cloud.
Hmm.
Um, and then, certain use cases just became really obvious, like, serving up imagery from Mars, right? You don't want to build data center and network infrastructure to maintain that level of activity all the time. And
Right.
so people started getting more comfortable with moving apps to the cloud. And of course, we had the cloud first mandate and now the cloud smart mandate. But you do raise data privacy and compliance issues, right? When you have to make these decisions, especially about
Absolutely. Yeah,
putting training data, in something that's not yours.
absolutely. I mean, there are going to be organizations that are going to train their own models for exactly those reasons. They've got concerns about the privacy of the model itself or the data that they're using to train it. Um, they might not want to put that into or into a cloud, and that might drive them towards doing something on premises.
Right.
Um, but that's the big trade-off in terms of data privacy versus cost that we need to be thinking about, because even though there are significant costs to doing something in the public cloud, it's sometimes easier to consume because it's operational. We're paying year by year or month by month rather than trying to dig, a whole bunch of coins out of the couch to go pay for a big system this year.
There are no coins in my couch anymore. I'm sorry.
Not
That
of that size, that's for
that
sure.
that account has been depleted. Um, we I'll point back to the whole, data center is the new unit of compute. And,
Mhm.
I know as we've talked, we've kind of seen this movie before, and you have some good history lesson with, what happened with early supercomputing, for example. Uh,
Yeah.
you know, what we've seen these impacts before. What lessons have you learned from that?
um, that's it all kind of repeats itself, I think, really. The
Right.
idea here is to build in a way that allows us to scale, build in ways that are repeatable. Don't make things overly complex. Don't build a one-off, because as soon as you build a one-off, you've kind of gone down this path of, well, the next one's going to be a one-off too, because this one was, and we didn't think about, do your homework. Think
Right.
about what the services are that you absolutely need to support in that infrastructure, what you want to deliver to end users, how you want to deliver it, where you want to deliver it from, and then think about the ways where you can do that in a scalable and repeatable fashion. Um, we talked about we talk about supercomputing. I like to think about the old iconic Cray one,
Sure.
that big cylinder gear looking thing, that was a wonder of its time. That's kind of what a data center is now, whether we're talking HPC or AI or even
Hmm.
enterprise. It's
Sure.
we're exploding that design across a room or a building and building it from off-the-shelf components. Um, there was a lot of complexity inside that very elegant chassis, that we never saw. We just interacted with this thing through a terminal screen, and that goes for both users of the system, but also the
Sure.
operators.
Sure.
And so that raises important questions now, right? How are we going to sort of abstract away the complexities of every one of those major subsystems, the compute, the storage, and the networking? And once we've done that, then how are we actually going to orchestrate across those subsystems? Um, that's why we have platforms like OpenShift and S3 for things like compute and storage. And it's
Right.
why Juniper has Apstra for networking.
Yeah, there's too much going on for me to go and hand jam configurations in a terminal window anymore. I need tools that are
Absolutely.
smarter, that do a lot of this work for me and don't necessarily tell me where data is geographically or where a workload is geographically.
Hmm.
As long as I know I have access to it and the latency is low enough, that's all I need to know in certain
Right.
instances. So yeah.
Absolutely.
We can't ignore security, right? It all needs to be connected,
It
but
does.
we as an industry, sorry, Scott Roban's opinion, we don't ever seem to do a great job of security first thinking. And so many things are an afterthought.
Mhm.
I know you have some opinions on this. What are you seeing from a data center security perspective and opportunity in what's happening?
Yeah. I think the fact that we're going through this transition right now gives us a lot of opportunity to do things better this time around. And again, I think it's a place where the way the data center has evolved potentially creates some complexities around that, but also gives us the ability to take advantage of scale out architectures and some more fungible components that we can deploy to secure things properly. We talk about this framework of a secure automated data center solution.
Hmm.
You'll hear a lot of folks talk about zero trust, and I think that's great, but we really need to talk about what that means. Um, and the first thing we need to do is acknowledge that that's not a box. It's not a switch. It's not a
Right.
firewall. It's not a piece of software. It really is a framework that needs to be part of the design from day zero, from the planning stage. And in a modern architecture, it's going to have elements everywhere across the environment. Obviously, you want to stop the baddies before they get through the front door. You also want to know if something in your environment is trying to call out to those baddies. That's going to be a firewall and some sort of an advanced threat protection suite. That ATP is going to live in multiple places. Some of the components might be cloud hosted, some might be on premises, and some might be completely host based. The next thing is that you want to ensure that the people accessing the applications and services inside your data center are allowed to do so. And that's traditional AAA type stuff. Again, it's going to have components that reside across some combination of cloud, premises, and hosts. But then we also now need to make sure that the applications and the components themselves inside that data center, that we are permitting the interactions that need to take place while limiting the ones that don't. Some of that's going to be more firewall, though this time the firewalls are going to be distributed across both the physical network and the hosts themselves. But and this is really important, it also means very smart placement of the applications and the components themselves that live inside that environment. What it is not, and what it certainly should not be, is writing a bunch of ACL rules that you're going to try to implement in your switch network. And that's for a couple of really important reasons. The first is that the type of memory that we use to implement those rules in a switch, it's a relatively scarce and very precious resource. It's something that's going to be very easy to overrun if you've got a medium-sized network with lots
Mm.
of application components that you need to control. The second thing's more important, I think, and it's just organizational. I mean, I've been in this environment now for more than 30 years. I don't think I've ever seen an organization where the network team and the applications team and the security team are a tightly integrated, well-oiled machine.
Right.
Lots of organizations really have no idea what's physically on the end of every switch port, let alone what applications are flowing over it. And if you think you can write the thousands of ACL rules it takes to properly enforce application security behavior at every switch hop, I wish you the best. I really do. Um,
Right.
so build out that environment for sure. Build out your zero trust solution. It's got to be in layers, test it regularly. And I think most of all, make sure you're interacting with the other silos every day to make sure that you're getting it right.
Yeah, you are not wrong. And in so many of the conversations that I have with other client engagements, um, this is a very typical problem, like
Oh yeah.
lack of communication across, like, validating what you've already said here. And we've just got to keep finding ways to encourage our clients to have a more holistic view of all the IT pieces, all the data center pieces, and how they interact. Now you've set up the challenges here and kind of hinted at, well, there are tools and AI related tools that can help me do the security operations and do the networking operations. Let's
Mhm.
touch on that a little bit and the whole topic of AI for operations, or AI ops and networking.
Okay, yeah, we should absolutely talk about that. And let's talk about, let's start this way. I like to separate my understanding of networks and how we manage networks into two distinct components. The first one is context. And this is a fundamentally declarative thing. What do I know in concrete terms about the network? I'm looking for very clear rules and behaviors, things I can test and validate. Uh, Given that some interface at the end of a fiber fails, I expect that the peer interface is going to report link down.
Sure.
Given that those interfaces are both down, I expect that if there was a routing protocol session between them, it's going to drop. So
Right.
you get the idea, right? Context
Yep.
is really foundational to our understanding. The other side there is insight. And insight is much more about things that I can infer based on context and previous experience. Um, so for example, when that link in that routing protocol session fail, I think that it's likely that I'm going to see some other links in my network start to run a little more hot to take up the slack.
Hmm.
Or if I'm sending a 3 terabyte database set over a particular path across my network, I'm going to assume that other applications that use that same path are going to be negatively impacted by that. So that's insight. And I really think that's the domain where AI ops has the opportunity to help us immensely. Um, I think it's going to be a powerful tool in our belt going forward, but I think we do need to really recognize and understand the limitations. Uh, no amount of AI is ever going to provide context. It's
Mm,
only ever going to provide insight. And we really do need both to truly understand this living, breathing entity that is the network. It's actually one of the reasons I'm really excited about Juniper's recent announcement around the integration of Apstra and Mist.
mm,
Uh, Apstra is all about context. We take a data center network design and we encode it in a graph database. And that gives us a data store that not only tracks all of the elements in our design, the switches, the interfaces, the protocols, but it also tracks the relationships between those elements. And that's our context, our foundational understanding of the network as a system and not just as a collection of boxes. And it's a foundation that no other tool in the industry provides, certainly not at the scale and diversity of vendors that Apstra does. And then on top of that, we now get the benefit of what I think is the best AI ops platform in the industry today, and that's Mist. And what Mist provides us is insight to help us understand how the network we built with Apstra supports the applications and services that we deliver over the top. So now we can see where our services and our consumers live in real time. We can infer from the state of the network how those services and consumers might be impacted. And we can even do the opposite. Given the current experience of our services and our consumers, we can start to infer the current state of the network. And so that's like really bringing those two hemispheres of your brain together, this context and insight, into a single platform.
yeah, the combination of that's a helpful distinction, right? And context certainly needs to be input into model training,
Yes.
right? And that's a longer conversation for another podcast. We can definitely touch on that. But
Hmm.
I agree with you. Like there's so much potential for more effective network and data center operations through these AI-based tools. And
Hmm.
it's great to hear what you're doing, with the coming together of two really successful product sets that have complementary info, and now you can provide insight across a bigger picture.
Yep.
So
Absolutely.
let's before we run out of time, let's pivot to the networking infrastructure for AI training. And
Hmm.
everybody's heard about this thing called InfiniBand versus Ethernet. Um, Give us the short version of what the non-practitioner needs to understand about the two different families of technologies.
Sure. So the InfiniBand really grew up around high performance compute, HPC. I've seen a lot of applications in HPC that are InfiniBand, once upon a time because they needed to be, but in a lot of cases now because that's the way they've always been. Um, we can
And it's a
argue that
mature it's a mature ecosystem,
it
right?
is
I
a
mean,
mature ecosystem,
yep,
and certainly some of the issues between, with trying to do that in Ethernet traditionally have been a lack of maturity on the Ethernet side. I'm not going to debate that at all or doubt that at all.
right.
But I do think that over the course of the last decade or so, a lot of what we use InfiniBand for could also be Ethernet. Um, there are still certainly use cases where InfiniBand delivers real benefit, and that's particularly where the most significant performance limiting factors are latency. Um, but there are lots of use cases where Ethernet performs just as well and at a reduced cost, both in terms of the hardware and the people. The talent pool for IB experts is much smaller than Ethernet because it really was something that evolved out of the high performance compute space and not so much the larger enterprise data center space. The hardware comes at a premium too. So from a cost perspective, it makes good sense to try to limit the InfiniBand domain to the places where it delivers clear performance benefits. And then for the rest, it should probably be Ethernet.
And you know, is there one version of Ethernet, Greg?
No, there is this idea of Ethernet.
Right.
It's definitely the little protocol that could, and it's something that's evolved over decades. My joke tagline for Ethernet is good enough networking for 40 years.
Right.
Um,
Right.
it's evolved considerably. But in doing so, it's outlasted technologies like Token Ring and FDDI for the LAN space, SMDS and ATM in the WAN, ATM also in the LAN. Um,
Wow.
and I'm hopeful really that the work that's coming out of the Ultra Ethernet Consortium right now is going to lead us to improvements in performance around both AI workloads and also HPC. Um, on one level right now, I think you're seeing lots of interesting innovations around traffic management for AI workloads. But that's coming directly from the vendors right now.
Hmm.
And my hope is that the UEC can help sort of tame this Wild West and provide a suite of more standardized vendor neutral technologies that are going to allow for real interop down the road. I'm also hopeful that the UEC can help chip away at IB's leadership in HPC. A single networking technology for all of it means simpler solutions at a lower cost of operation.
Right. I think we've seen the whole industry benefit from the ability of Ethernet to evolve. And
Absolutely.
I probably don't have this quote exactly correct, but I think Bob Metcalf, the father of Ethernet, ha- may have said, "I don't know what the next generation of networking will look like, but it will be called Ethernet."
Exactly.
So. And there, that's funny, and we can chuckle about it, but there is an industry that understands the basics of, what the physical layer and what the logical constructs are of Ethernet to adapt to different network conditions.
Yep.
And it's more than, you know, a sea change with each evolution. It's always building on what's come before. And the bottom line for me is don't bet against Ethernet. So
Yeah.
there always be some InfiniBand, but I think we'll just see Ethernet adoption, especially with the UEC work, continue to grow. So,
I would agree. Yep.
well, as we start to round out here, let's make sure we go back to that whole cloud consumption discussion and this new phrase that's out there called neo cloud.
Mhm.
Um, what is a neo cloud provider and what's it good for, Greg?
All right. Let's talk about that. And let's start with a bit of a definition. I like to think of neoclouds as organizations that are solving for the training as a service market.
Hmm.
So again, dialing back to this
AI
idea,
model training.
yeah,
AI
AI
model
model, sorry,
training.
yeah, AI
Yep.
model training as a service. So we dial back to this idea how AI is leading these physical transformations in our data center, and how most of that is really due to the demands of training an AI model, something that realistically most users of AI are not going to be doing on a regular basis. So if we can, it really does make sense to sort of outsource that training to a provider that's optimized for that function. Once we have our trained model, then we can run inference on that all day in an environment that looks a lot like the modern enterprise data centers that we're deploying and operating today. Um, Globally, there are going to be organizations that perform their own training, certainly. And as we've talked, whether that's due to things like sensitivity of the model or the data,
Mhm.
um, maybe it's the frequency at which they want to retrain or train new models, and also simply because they have budget and they're going to do it.
Yeah.
But I think that's a relatively small set of organizations, and that's true both globally and inside the government. For most organizations, it's going to make a lot more sense to outsource that training, whether that is training as a service via NeoCloud, or maybe just making use of an off-the-shelf model rather than a custom model. And the places where we need that model to make use of some proprietary data, we can vectorize that data set and do what we call retrieval augmented generation locally. So
Mhm.
we don't have to train a model just because we have proprietary data. There are other ways to get there that don't require that we go through a full training. So yeah, neoclouds absolutely they provide an important function. I think it's one that we are going to learn to take more advantage of as we go down the line. We are seeing some improvements in the way we build out AI training networks right now, where we're doing things like supporting multi-tenancy better, both at the GPU layer and also at the networking layer. And I think as those solutions get more robust, I think the solution becomes a lot more attractive to more organizations.
Yeah, I've had some other conversations in this podcast series that talk about, not just renting clusters, but the neo cloud providers building their own orchestration layers,
Hmm.
coming up with their own version of the AWS console, right?
Yep.
Or and helping you manage what's happening within the environment. Um, I'm sure there'll be similar security concerns to neo cloud usage as we had for cloud adoption early on.
Hmm.
How do you see that changing or being any different for adoption of neocloud, or will we see, just as an example, would DISA, create their own neocloud service that DoD entities could take advantage of? And I'm just thinking out loud here. I don't know of anything specific there.
Yeah, no, and nor do I at this point. We're certainly talking to lots of folks in DISA about a
Sure.
range of data center related things. Um, it might make sense. If you just look at where we are with public cloud in general right now, um, we have pretty good coverage for unclassified space with things like FedRAMP.
Sure.
We are replicating clouds in different classified environments as well. That's very large scale. Um, we'll probably end up doing something similar for training. I would think so. Um, I also think that there are some folks that aren't necessarily DISA who have some ideas about how they could contribute to that
Sure.
environment as well. I think we're going to see. I think we're going to see a handful of neo cloud providers in the secure space as well,
Yeah.
just focused on that industry. I do.
That would make a ton of sense. And again, that's from very much, more than arm's length from my perspective today.
Yeah.
Um,
I mean,
do you, s-
if you're already trusting your data and your applications in some of those environments, this is more data and a different application, but fundamentally the same types of concerns around it. So if you found a way to do one, I'm sure you'll find a way to do the other.
well, I just heard of, do you remember the Mary Meeker State of the Internet reports and briefings that she did from,
Hmm.
90s into the aughts? She's now doing an AI related, 364 slide deck. And I need to take a close look at it myself. But one of the key things I took away from an overview was the time to get to 50% adoption for each of these technologies. And if you compare um, mobile and cloud, you saw a longer time for 50% of people to get to mobile usage,
Yeah.
and then less time to get 50% of organizations to cloud usage. And now we expect that time to 50% adoption for AI in general to really be much more compressed. Do you think that will help the neo cloud infrastructure discussion with federal customers?
I think it does, and I think it's important to understand too that in a lot of ways, neo cloud is just a use case for cloud, and we've already sort of hashed out some of we sort of know the process for cloud. We've built
Sure,
that pathway now, right? So now this is a different use case. We need to consider the specifics of that use case, but it's not new infrastructure in the same way that wireless or even public
sure.
cloud the first time around was new infrastructure.
Yeah. All of these things build on the technologies that came before them,
Right.
right? And the
Hmm.
reason software can eat the world today is because there's a global, highly interconnected internet over which software can be delivered.
Exactly. Yeah.
So, very good. Well, I'm going to give you as our round out conversation, your opportunity to talk about key items that you really, really wish data center operators and architects and others should put more attention on for network infrastructure. This is your chance, Greg. It's just you and me talking. Nobody else is listening. What would you really like people to pay better attention to?
All right. I'm gonna get up on my soapbox for this one, and I
Okay.
have to admit that even from my standpoint, um, although I have felt the need for a very long time, um, recent events have really run it home, and so it's come from what was a pet peeve to maybe now a pet project. And that really is to push anyone in public sector to really consider a multi-vendor strategy. And when I say that, I'm not just talking about something that we're going to write into a planning document. It has to be something that we practice every day, starting now,
Yeah.
so that we're actively executing against that strategy when life forces us into a place where we desperately need it. Um, I will tell you, like I said, I've spent nearly all of my professional career. I spent all of my professional career in IT. Nearly
Mhm.
all of that has been supporting the U.S. government, and that's been everything from speeding up processing of travel visas to tracking terrorists and COVID infections to
Right.
ensuring that retirees get their Social Security checks on time. Um, Public service matters,
Yeah.
and from my perspective, it's how we make the world a better place for everyone. And the reality is that people are going to rely on government services most when times are the toughest. So we can't just not deliver for our citizens because of the classic, my people only know Cisco. And it's going to take me
Right.
12 months before Cisco can deliver the switches I need to build out my infrastructure and actually deliver those necessary services. And I want to be clear and I want to be fair. I'm not picking on Cisco because they have some unique supply chain failing.
Sure.
What happened with the supply chain during and after the pandemic was really an everyone problem. It's just the statement I've heard over and over from networking shops, and I've heard it for more than 20 years. And what I would say to you, if you're an architect or a group chief or a CIO, and that's your statement to me today, my people only know Cisco, then in my opinion, you failed. Your people haven't failed. It's really your job to meet them where they are. But make no mistake, what you've set yourself up for is you've set yourself up for this situation where you've built an environment where you can't guarantee that you're going to be able to deliver a service reliably when that service is needed most. And why do I say that? I think if you just consider human history, we got really lucky between 1945 and 2020.
Hmm.
We had a century without a global or even a national pandemic. We didn't have any sort of global or continental scale conflict from World War II up to that point. And we need to appreciate how truly unique that period was. So let's talk COOP. How are you prepared for an avian flu pandemic if it explodes across the world next year? How are you prepared for a 9/11 style attack that takes out a bunch of major international seaports? And the reality is you have to be ready before anything like this happens. So build that muscle and start to use it. Start that transition now when times are still good, because you never know when times aren't going to be so good. You've got people in your organization who are going to pick up everything new that you throw at them in a week. And you're going to have others who are going to struggle with anything new for years to come. And your people are going to be at both extremes and across that entire spectrum. So as you design a system, critical to that design is how you're going to deliver a multi-vendor solution that your people can actually manage and operate. We can't be married to a single command line, and really, we shouldn't even be married to a command line anymore. So, how are you going to lower that barrier so that all of your ops team are capable of effectively managing your network, regardless of the command line they got certified on? Some of that will absolutely be homegrown automation. Some of that will be off-the-shelf tools like Apstra, tools that can abstract away the implementation details of a design and let you focus on declaring intent. But I think that is totally critical, because I think the likelihood of us going another 75 years before the world is on fire is pretty low.
Right.
So,
Right.
so with that, I'll
I
step off my soapbox.
No, I think that's a perfect way to wind this down. And let me just underscore the import of what you just said. As a representative of a particular vendor, you just called out those higher order goals, right? Government needs to be there when people need it the most. I think I quoted you almost 90% correctly there. Um, and this draws together multiple things that you called out during the conversation today: the need for standards to have interoperability. You can also expand what you just said. It's not just a networking thing; it also applies to the compute, the orchestration software layers, the storage layers.
Mhm,
Any of these areas of data center construction and operations, I need to have redundancy and reliability, and where I'm
mhm.
sourcing all the pieces of the puzzle.
Yep. Yeah, I think the good news is that in some of those other domains, I think we've solved this problem a lot earlier. I mean, we
Sure.
think about, we don't deploy a Cray as our data center anymore, right? We deploy Supermicro and Dell and HPE
Yep.
across racks or pods inside our data center, and they're all running some flavor of Linux on top of that, right? And applications sitting on top of that in an environment like Docker or Kubernetes or OpenShift. Um, so I think we've solved a lot of the problems on the compute side. I think the storage is probably not as solved as the compute problems are. And I'm concerned sometimes that the network seems to be the least solved of all of this. Um,
Right.
I think we get there. I think that's some of the interesting work around Sonic. I don't think Sonic is fully baked yet. even if I think about just the compute side of that, it was really a good, 20, 25-year journey from we have these, we've kind of standardized on x86 as the platform to rule them all now. And ironically, it's
Hmm.
not necessarily that anymore. We're seeing a lot of ARM. But
Sure.
but think about how long it took to go from the early versions of Linux to things that we might even consider running on a laptop that we're going to give to our parents or to our kids, right? It took a
Right.
really long time to get there.
Yeah.
Um, and I think we're going to see the same thing here. I think the end goal is that we end up with an operating system like Sonic that runs on merchant hardware. We figured out how to integrate it. We figured out how to operate it. Um, but there's a lot of work to be done.
I will say that for Sonic today compared to 5 years ago, I'm seeing increasing traction and momentum and people that are
Mhm.
willing to go with open networking solutions. And yes, it does involve taking on responsibility. It takes more work, quite literally. You know, if
Oh
you play the
yes.
role of an integrator of this open source routing and switching software on, open networking hardware, but that can be part of your multi-vendor strategy, right? It can all play in there. So,
Absolutely. Just you need to understand the implications of being that integrator.
yep,
You need to make sure that the people that are, that are staffing your environment are capable of doing that, right? This is the thing that's really important is that if you think about a network team in modern sense, you've got the CLI jockeys, the ones that really understand the networking. You're going to need folks that understand integration and all of the criteria that go around that. It's not just putting an operating system on a switch. It's testing it as well and making sure that things behave the way that you expect. And it's automation. Just from personal experience I guess about a decade ago, within the organization I work with at Juniper, we were looking to bring in another engineer. And we had this big debate about what we needed that engineer to do. And I said, look, I don't want a networking guy. I want an automation person.
sure.
I can sit that I want them to be networking adjacent. I want them to at least understand the terminology. But what I really want is to have a conversation with that automation expert and say, this is what I need the network to do and when I need it to do it. And then if you can figure out how to automate that process, we end up in a much better place. And so the networking teams are going to look a lot different than they should look differently today than they looked 10 years ago. And they should certainly look different going forward than what they looked like 10 years ago for sure.
You just teed up our next conversation. Come back for a future episode with Greg on why network automation needs to be the new standard for networking in the data center and beyond. But Greg, thank you so much. Really, really important commentary and observations on what's happening in data center networking. At Caresoft, we really appreciate our relationship with Juniper Networks and the way we work together to serve our combined customers. So thank you for that. Let me as we go out here, do you have any final thoughts or big ideas you want to share, or where can people find you if they want to follow up?
No, if you wanna find me online, I don't have a big social media presence. I am on LinkedIn as Terp EE93. I am a University of Maryland graduate with a double E.
Proud Terp.
There
Yep.
you go.
Yep.
Yep. Otherwise, it's juniper.net. Talk to your account teams, talk to Caresoft. They've been a great partner for us. We just wrapped up a Beers with Engineers happy hour event last week. We'll be running an online version of that series next month. So if you want to, DoorDash some wings and have a cold one while we do that, by all means.
Very good.
And as always, Scott, it's great to talk to you. I've known you for a long time, and I always happy to chat with you.
Same here. It's always good to talk with you. Thanks, Greg. We really appreciate you coming here today and Juniper Networks work in the public sector and with Caresoft. Listeners, thank you for tuning in and be on the lookout for more episodes coming soon in the Caresoft Data Center Innovation Series. Thank you and talk to you soon.